So how well do we do it? Is it fair? The answers to these questions is the basis of studying voting theory, and that's what we're going to talk about this chapter. So it may seem obvious and straightforward. Just count the ballots and use that count to determine the outcome of an election in a consistent and fair manner. But surprisingly, it turns out that in an election that has 3 or more choices, there is no consistently fair democratic method for choosing a winner. So whether you believe me or not right now, you will at the end of the chapter, because we're going to study this counterintuitive result. It's called Arrow's impossibility theorem. And we're going to study it by examining several different methods of vote counting and seeing how each one fails. So let's start out with a simple vote. Let's say I was going to show a movie in class. I'm not, but let's say I was going to show a movie in class. Give me 3, somebody nominate a movie that you'd like to see. Shawshank Redemption. Meet Joe Black. E.T. Great. Okay. So now each of you individually are going to cast something called a preference ballot. You're going to write down your first, second, and third choice from the choices given. So just put your choices down from first to last. I'll put mine down. Let's see. All right, everybody have your choice recorded? Okay. So now we're gonna before we collect the aggregate data of the class, we're going to talk a little bit about what a preference ballot is and some of its properties. So a preference ballot is one where you rank all the choices. Rather than just circling the one you want, you rank all your choices. And the great thing about preference ballots is that a voter's preferences are transitive. Okay. Do you guys know what transitive is? Yeah.
That's if A equals B and B.
You got it. That's called the transitive property of equality. If A equals B and B equals C, then A equals C. Other things are transitive as well, like preferences, right? So if I like C better than A, and I like A better than B, everybody can conclude that I like C better than B. Okay. Right. Yep. So I know that I like C more than A, and I like A more than B. So by the transitive property, so by transitivity, I like C more than B. I'm using that greater than sign just to mean more than as a shorthand, so I don't have to write so many words. So because of this transitive property, relative preferences are not affected by the elimination of a candidate. So given that you know I like C better than A and A better than B, if candidate A drops out, you know how I would vote, right? I don't have to recast a ballot if somebody drops out of the election. Say, you know, I'm going to show this through Netflix, and I go to Netflix, and it turns out that Shawshank Redemption isn't available, right? You still know that I would vote CB, right? If this one's not here. Okay, so the order doesn't change. Okay, so now we're going to gather all of our voting information for the class into a table called a preference schedule. So there's only so many ways people could list their choices. We've got 1, 2, 3. Okay. Sorry, sometimes my notebook doesn't print all the lines. All right, so I could choose A, B, C. So if A were my first choice, I totally want to watch Shawshank Redemption. My second choice and third choice could be BC or CB. So I could have ABC or ACB. Those are two ways that I could vote. If B is my first choice, right, Meet Joe Black could be my first choice. And if that's my first choice, my second and third choices could be AC or CA. And if C is my first choice, my second and third place votes could either go AB or BA. So there are 6 possible ways that someone could vote, could cast their ballots in this election. All right, raise your hand if you voted A, B, C. We have 3. We have 3 people who voted A, B, C, so we put a 3 at the top of that column. Okay. Hi, you here for Math 117? Come on in, have a seat. Here, and let me grab you a syllabus. Okay, so raise your hand if you voted ACB. We got 2, okay. And anyone vote BAC? 1, 2, okay. Any BCAs? 1, okay. CABs? Was that mine? Did I vote CAB? I think I did. Yep, okay. So CAB will be 1. And any CBAs? 3. Okay. Nobody voted twice, right? Okay. So now, this is just a nice little summary of how everybody voted without having to have a stack of ballots. And before we answer this question, without counting the number of people in the room, how many people voted? $12, yeah, because you can count up the ballots. There were 3 ballots that look like this, 2 ballots that look like this, so we just add them up. 3, 5, 7, 9, 10, 12. So what movie do you think should win? Why do you think that? Yeah, so 5 people have Shawshank Redemption in first place. Okay, so because it has the most first place votes. Anybody think that there's a case to be made for showing a different movie than Shawshank Redemption? That there's any reason that we should show something else other than Shawshank Redemption? No? Right. Okay, that's all right, that's fine. So method 1 for choosing a winner is called the plurality method. It's the most common and best known method for determining the winner of an election. It's a natural extension of the democratic principle of majority rule. Okay. So majority rule states that in an election between 2 candidates, the candidate with the majority of the votes should be the winner. Okay. Now, what is a majority? More than half. It's not necessarily the most. It means more than half. Okay. So the plurality method says that in an election between 2 or more candidates, the candidate with the most first place votes wins. You just have to have the most, not necessarily a majority. Okay, but the most first place votes. So in the plurality method, you just have to have the most votes, the most first place votes. Okay. To get a majority, you have to have more than half. Okay, but you do not need a majority to win the plurality method. So let's go back to our preference schedule here. We said that Shawshank should win because they have the most first place votes. How many first place votes do they have? 5. Okay. They have 5 votes, right? And we said 12 people voted. So does Shawshank have a majority? No. They win though. That's okay. Okay, so I'm just going to put a little note here. Shawshank does not have a majority. They won because they have the most, but they do not have more than half. How many would one of the movies need to have a majority? How many votes? 7. Yep. Yep, 7 would be more than half. So in an election that has only 2 candidates, what can you say about the plurality candidate? Whoever has the most votes, what else can you say? Also has a majority. Yeah. If there's only 2 candidates, then the person who has the most votes also has a majority of the votes. Does that make sense to everyone? So if you have the most votes out of 2 people, you have to have more than half. So using the plurality method, which movie should the class watch? Shawshank, right? We decided that already. We just didn't know that the method we were using is called plurality method. All right, so what are some advantages that you can see of determining a winner this way? What are some advantages of determining a winner using the plurality method? By making the winner the person with the most first place votes. Yeah. Why is it good? Why do we do it? More detailed?
Because whoever gets the most votes wins no matter what, and everyone counted it, right?
Okay, so that's a good thing. It has an advantage of any method is that the people participating have to understand it, right? Otherwise, they're not going to have faith that the winner is the real winner, right? So it's pretty easy, clear, understandable. So it's a relatively straightforward method that people can understand. So those are really strong advantages. We like it for that reason. Now, can anybody come up with a disadvantage? Any reason that's not? You can win without a majority, yeah. And in fact, when there are a lot of choices, like let's say there were 10 choices, you could win with a very small percentage of the votes, right? You could win with 11% of people voting for you. Okay? So not only can you win without a majority, you can win with a very small percentage of votes. Not even just, 40%, but you could win with as small as 1% if there were 100 choices. Yeah. So let's write that. You can win with a very small % of votes if there are a lot of choices. Mm-hmm. Right. Right. Yeah. If you have more than 2 candidates, you can't require a majority to win, because very often there would be no winner. All right. So for an election to be considered fair, it has to meet certain criteria. Okay. We're going to study a few of them. Here's sort of our first and most basic expectation of a fair election. It's called the majority criterion, and it says that if candidate X gets a majority, so in the event that they get a majority, they should be the winner of the election. So it's not a requirement, but if someone has a majority, we think that they should win. Okay. Yeah. So does the plurality method satisfy this? If somebody gets a majority of the votes, are they always going to win? Okay, so let's say there's 3 people. Let's say 3 people and 100 voters, okay? And we're going to give candidate A 51 votes, a majority. They're going to automatically win because there's only 49 votes left and they have to be shared between the remaining 2 candidates. B and C together, only 49. Okay, so yeah, if somebody gets a majority in the plurality method, they are always going to win. So that's another advantage of the plurality method. There's no way that you can get a majority of the votes and lose. Okay. Which sounds pretty straightforward and obvious, but there are methods where that can happen, that you could get a majority of the votes and then lose the election. And we'll study some of those in the upcoming weeks. So maybe we should add that to the advantages. Okay. It always satisfies the majority criterion. Meaning it is impossible to get a majority and lose. You can win without a majority, but we have not violated this criterion. Okay, so this can be very confusing. So here's my example of how I explain it. I'm making this up. I really am not a runner, but let's pretend that my rule for myself is if it's not raining outside, then I will go for a run. Okay, this is my rule. If it's not raining, then I will run. So let's go through a couple scenarios. If I wake up and it's a beautiful sunny day and I go for a run, have I violated my rule? No. Okay, if I wake up and it's raining and I don't run, have I violated my rule? What if I wake up and it's raining and I run anyway? No, my rule is that if it's not raining, I must run. It says nothing about what I'm going to do if it is raining. I still have the choice here. Okay, so if it's raining, I can run, I can go out and run, or I have the option to stay home because the rule just says that if it's not raining, I will run. If it is raining, I can either skip it or I can go out and run without breaking the rule. Okay. I said my rule is if it's not raining, I will go out and run. If it's not raining, I will run. Okay. So if it is raining and I don't run, I'm okay, right? Have not broken the rule. If it is raining and I do run, have I broken the rule? have not. Okay. So here's the rule now. Now that I translate back to here, it says if a candidate has a majority, they should win. Okay. So let's go through the 3 different scenarios here. So let's say a candidate has a majority, they have more than half the votes, and they win. Have we violated this rule? Nope, they got a majority and they won. That's supposed to happen. Okay. Let's say a candidate does not get a majority and they don't win. Have we violated this rule? Let's say a candidate did not get a majority, they got less than half the votes, and they do not win. We have not violated the rule, right? Okay. Let's say a candidate does not get a majority, but wins. Does not violate the rule, right? The only way to violate the rule is that someone has to have a majority. They have to have a majority and lose. That's the only way to violate this rule. Right. We'll get there. We're going to talk about that soon. So I'm going to write this down here to make it clear. The only way to violate this rule is if a candidate gets a majority and loses. Okay. So this rule is only about if you have a majority. If you have a majority, then you should win. If you don't have a majority, it doesn't say anything that should happen, right? So if you don't have a majority, you can never violate this rule. Nobody has a majority, this rule cannot be violated. The only way to violate this rule is if a candidate gets a majority and loses. Okay, this one says that if a candidate is preferred by the voters over every other candidate in a head-to-head comparison, then candidate X should be the winner. Okay. So the only way to violate an if-then statement is if you satisfy the if part and break the then part. Okay. So I know that this if part is a little bit like, what the heck does that mean? We're going to do an example to explain it in a second. So let's look at this example. We have Tasmania State University's marching band. They have been invited to perform at 5 different bowl games: the Rose Bowl, the Hula Bowl, the Fiesta Bowl, the Orange Bowl, and the Sugar Bowl. And the results of the voting by the 100 members of the band are in this preference schedule. So 49 people voted Rose Bowl first, Hula Bowl second, Fiesta Bowl, Orange Bowl, Sugar Bowl. 48 people voted Hula, Sugar, Orange, Fiesta, Rose, and 3 people voted Fiesta, Hula, Sugar, Orange, Rose. So according to the plurality method, who should win this election? Who's got the most first place votes? The Rose Bowl, yep. The Rose Bowl with 49 votes. Oops, I just skipped something. So let's take a better look, a more close look at the voice of the band though here. We have 49 people chose the Rose Bowl, but the other 51 people, the other 48 plus 3, where did they rank the Rose Bowl? Last. So we have a majority of people who do not want to go to the Rose Bowl, right? That is their last choice. So the plurality method may not be fair in this instance, right? And in fact, if you look at the Hula Bowl, let's look at the Hula Bowl, and we're gonna put Hula head to head against everybody else. Okay, so I'm gonna do Hula versus Rose Bowl, Hula versus Orange Bowl, Hula versus Fiesta, and Hula versus Sugar. Okay, so that's everybody, I think, right? Yeah, it's everybody. Now, because we know preference ballots are transitive, we can tell in any given person if they would choose hula or rose if they had to choose. So let's look at these first 49 people. If they had to choose between the Rose Bowl and the Hula Bowl, who would they vote for? The Rose Bowl, because they have them ranked above hula. So we've got 49 for hula. What did I do? Okay, so I have 49 for hula there. Now the next 48 people, if they had to choose between the Hula Bowl and the Rose Bowl, who would they choose? Hula. They've got it ranked way above Rose, right? So 48 would choose hula. Oh, sorry, the 49 chose the Rose Bowl. Silly. 49 and then 48 chose hula. And then the last three people, if they had to choose between hula and rose, who would they choose? Hula, because they have hula ranked above rose. So we're going to give 3 more votes to the Hula Bowl. So that means hula ends up with 51 votes, Rose Bowl with 49. Hula wins that head-to-head matchup. Now let's... Right, yep. Because when you have a head-to-head matchup, someone will always get a majority. Yep. So let's look at hula versus orange and see who wins. So these 49 people, if they had to choose Hula Bowl or Orange Bowl, who would they pick? Hula. How about these 48? Hula. And these 3? Hula. Hula is ranked above Orange in all 3 columns. So we have 100 votes for Hula, 0 votes for the Orange Bowl. All right, how about Hula versus Fiesta? 49 people, Hula. These 48 would choose Hula, ranked way above Fiesta. And these 3 would choose Fiesta. Okay, so we have 97-3, Hula to Fiesta. So Hula wins that one. Sure. You look at who's ranked above who. So like, I'm going to look at Hula versus Fiesta. Hula is ranked above Fiesta, so those 49 votes all go to Hula. Okay. And in this one, we had Fiesta above Hula, so these 3 votes go to Fiesta. All right, last one, Hula versus Sugar Bowl. So these 49 people, which one's ranked higher, Hula or Sugar? Hula. How about these 48? Hula. And these 3? Hula. So we have 100-0 choosing Hula over the Sugar Bowl. Hula. So Hula wins every single head-to-head matchup. That makes Hula a Condorcet candidate. So Hula should win. That's what the Condorcet criterion says, right? Hula is a Condorcet candidate. Condorcet. Yeah, it's French. Condorcet. It's the name of a person who invented the concept. Yeah. But who won this election in the plurality method? The Rose Bowl. No, when we did the plurality method, they had 49, the most first place votes, right? Rose Bowl has 49, Hula has 48, and Fiesta has 3. So with the plurality method, Rose Bowl won. Yet Hula's a Condorcet candidate. So we violated the Condorcet criterion. We have a candidate who is preferred by the voters in a head-to-head matchup over every other candidate that did not win. So this election violates the Condorcet criterion. The marching band election. Violates the Condorcet criterion because we have a Condorcet candidate and that candidate lost using the plurality method. Yeah. I'll say because Hula is a Condorcet candidate, that means that Hula is preferred by the voters in a head-to-head matchup over everybody else. But the Rose Bowl won. Nope. Does the plurality method in this instance satisfy or violate the Condorcet criterion?
Okay, so
Here.
I'm gonna write that.
Yeah. Violates the Condorcet criterion. Rose Bowl did not have a majority. They had the most. Mm-hmm. Yep. So this is a disadvantage of the plurality method, that it's possible to have a Condorcet candidate lose. So let's go back to our pros and cons list, advantages and disadvantages. And to the disadvantages list, I'm going to add can sometimes violate the Condorcet criterion. Okay, so sometimes when you're using the plurality method, not every time, but sometimes, certain situations, you can have a Condorcet candidate, someone who would win all of their head-to-head matchups, but not win the election. All right, let's look at our movie preference schedule. Do you think we have a Condorcet candidate? Ah, okay. I'm going to take a picture of this guy so we can do this on a blank page. Okay, so let's just do some matchups. Let's do A versus B. So these three people would choose A. These two people would choose A. So we've got 3 and 2. This next column, would they choose A or B? B. And this column, B. So we've got 2 and 1. And then my last column, I've got A gets 1 and B gets 3. 1 and 3. So they tie. 6 and 6. So right now, we can say that there's no Condorcet, unless C is Condorcet, and it's not, yeah. Because neither A nor B are going to be able to win all their head-to-head matchups because they've tied one. Okay. So nope, no Condorcet candidate. Condor-site candidates usually pop up in very polarizing elections, where a lot of people have somebody ranked first, but a lot of people have that same but somebody ranked last. So I guess our movie selection was not that controversial. So very quickly, we'll do our last major flaw of the plurality method, is the ease with which results can be manipulated by a voter or a block of voters through insincere voting. So in insincere voting, if you know that the candidate you really want has no chance of winning, rather than waste our vote on our favorite candidate, we might cast our vote for a lesser candidate who has a better chance of winning the election. Right? We might use our vote to prevent someone from winning rather than voting for the person we really want. Okay. So here's the marching band election, right? So these three lone people who really wanted to go to the Fiesta Bowl, okay, let's say they know before the election that nobody else wants to go to the Fiesta Bowl. They know they're the only three people who want that. Okay. How could they have changed their ballot to make an outcome, they know, given that they know Fiesta's not going to win, how could they create an outcome that they would be okay with? Yeah, they could switch their first and second place votes, and they could swing the whole election away from Rose Bowl to the Hula Bowl. Okay, that would be an example of insincere voting. They're not putting their first choice first. Instead, they're putting their second choice first to avoid having their last place choice win. Has anybody seen this in real life or remember an example of it? Yeah, Ross Perot. Yeah. Third-party candidates in our system make this happen all the time. Ross Perot, Ralph Nader, Bob Dole, right? So third-party candidates. In a two-party system. Sort of the most well-known one is probably Ralph Nader in 2000, where it was so, when it's so close between the two major parties, a lot of people who might have voted for Nader instead voted for Gore to prevent George Bush from winning the election, right? And that's the consequences of insincere voting in American politics, is that it's very hard to get a third party candidate to be taken seriously. Yep. Mm-hmm. People feel like they'll be wasting their vote. All right, so that's it. This is just a little list of things that you should be able to do after this class. Get registered for my math lab, and you can start the class 1 homework. No homework due this week. Next week, there'll be 2 assignments due. Yeah.
I'm like decently confident in my math skills. You know.
Okay.
I did okay in pre-cal, and but do you think I should buy this? I have no money.
You
I
have
need it.
cool. Homework is 20% of your grade,
Oh, and it's on.
and
here.
it's in there.
Okay.
Yeah.
Okay. Cool.
Yeah.
I'm sorry, I didn't understand
Yeah.
that. Gotcha.
Is this your syllabus here? Okay. Hi.
The last part I didn't get to do very hard to.
Take a third-party candidate seriously.